Hey everybody, so the first thing to check is to make sure that audio is working, and other than the VU meter I can't tell. So does this sound okay? Can people hear me just before I get going? Somebody say something please. Cool, thanks. I'm just using the built-in microphone on the computer, so it's probably not the best quality. Also, I'm going to, as I go through projects, what I'm going to do is probably go and grab hardware. I've set up a little camera just here looking down at the bench, so I can show you the design in Eagle and then put the actual hardware on the bench and show you if there's anything interesting. We probably won't be able to do that for every project, but for the ones that seem like it's worthwhile, I'll do that. The other thing is that this is only the second time I've done a live stream. The first time that I did it, I discovered that all of the comments and questions go through and basically disappear. They're not recorded as part of the live stream. So if I answer questions, I'm basically going to repeat it so that someone comes and watches the recording later, they know what I'm talking about. So my very vague plan for this, I don't really have much of a plan, is just to open up Eagle, start at the beginning of my projects directory, so it's just alphabetically sorted, and open up the projects and show you what's in them. Now some of them, in fact the vast majority of them, will be really quite trivial. There are a lot of little breakout boards. There are things like an accelerometer, which is a MEM sensor and a smoothing cap, and that's it. There's really nothing much else there. But there are some that are a bit more significant, so we'll probably spend a bit more time on those. And I really don't think I'm going to get very far through the list, but I can come back and do more later. So part of the reason for this, and also one of the reasons I'm going to just do 1 hour now, is that I want to use this as a way of kicking myself back into, oh, Spider Eye says he thinks comments are, he or she thinks comments are recorded now. Change to top chat to live chat if you haven't, otherwise you'll miss comments. Yep, okay, thanks. I didn't know that. So I need to look into the chat system a bit more if I'm going to do more of these. So what I want to do is use this as a bit of a way of kicking myself into working more on videos today. I've got a whole lot of stuff that has been done, partly done over time, and I want to get back into finishing off some videos and uploading them. Proper projects and tutorials and things. So I'll switch over to the iMac desktop, and that is my, so this is Eagle, and this is my projects directory as it currently stands. Now the resolution on this, it's like a very big monitor, so the resolution is quite small. You're not going to see a whole lot of detail at this level, but I'll zoom things in so that you can see what's going on. So this is projects that I've got in my Eagle directory. That's not counting stuff that's archived and things, so it's a bit of a mixed bag. And this is going to be jumping all over the place because it's all just alphabetical. There's no chronology to this, no real logic. Alex says, why Eagle? Okay, so I've used a few different bits of PCB design software over the years, and Eagle came about basically because when I finished work on practical Arduino and I was wanting to do some board designs based around Arduino, all of the reference designs like the DeMille Nerve at the time, I think was the current board, were all published in Eagle. And so what I did was took Eagle as the tool that was used for Arduino and just used it myself, so that when the designs were published, it would be in the same tool as other people were accustomed to using. There were some other pieces of software that are more open source. Eagle is definitely not open. It's a closed proprietary program, which is a downside to it. At the time, so this was nearly 10 years ago, probably the leading open source package was GEDA, and I think KiCad was still very rough and raw at the time, and I tried GEDA and I couldn't stand it, and I think its popularity has dropped off a lot. And KiCad in that time has matured, so that is a really good piece of software now. If you just start getting started in PCB design and you want to keep everything open, use open source tools. Sorry, I should be saying KiCad. I need that KiCad or KiCad t-shirt. Then KiCad is probably a good tool to use. It's just that because I ended up going down the Eagle path with those Arduino reference designs, I've ended up sticking with it. And Eagle's gone through a couple of periods where it's sort of stagnated, but now that it's owned by Autodesk, there's a huge amount of development going into it, and just in the last 12 months it's gained so many features that I'm kind of stuck with it. It's like a drug dealer where they keep giving you a little taste. Every couple of weeks there's a release with new features and you go, oh, this is fantastic, and then I never end up shifting to anything else. So not really a great reason other than that. So you're looking at nothing much at the moment. So let's get started. So 16x2 LCD shield. And I'll pull up the schematic, and some of these, whoops, I'm on the wrong screen. There we go. Because I've got a 3-screen setup here, what I normally do is have the schematic on one screen, the PCB on another, and the control panel on the third, along with libraries and whatever else and data sheets I often have then on the second row of monitors. I've got 6 monitors in total here. So this is the schematic for a 16x2 LCD shield. This uses one of those HD 44780 parallel interface, I think they are, modules, and it's just on an Arduino shield. This is a very old design. In fact, if we zoom in way down here, you can see copyright 2010. So this was one of the early products for Freetronics, and it's just got some input buttons on there. There's the display module connected through to headers on the Arduino, and it's kind of awkward, but I'll switch here. And this particular one was designed with all through-hole parts. Now I'm just going to change this. It's kind of annoying that the color on some of these old projects doesn't match what I currently like. And turn off some layers, turn off the place, that'll make it clearer. Okay, so it's just got a big module stuck right across the front here, and as you can see, this is through-hole parts. So the very first designs that I was doing for Freetronics, many of them were actually intended to be kits. Part of the reason that Freetronics exists is that after Practical Arduino came out, my original idea with the book was that it would be an explanation for how to go about approaching projects, and that people would then go out and seek their own parts and build projects that were inspired by the book, but not necessarily a direct copy. It wasn't intended to be like a follow step 1, 2, 3, 4, and then you get the end result. It was, this is how things work, how you build your own projects. And afterwards, a whole lot of readers contacted me and said, where can I buy the kits for the projects in the book, and that sort of thing. So Freetronics largely came out of that. It was a way of putting together kits to make them available for people who bought the book. And so many of the really early projects had through-hole parts and were sold as kits, or they were intended to be sold as kits, and then we just ended up selling them pre-assembled for simplicity. So that's why some of these old projects, you can see all of these through-hole parts. So I don't think there's anything particularly interesting in that project, other than if we go to this actually shows an interesting progression in the design. Now, one of the problems with the LCD, the LCD shields and the modules is they're very thick. So what we did for the second one. So that first board I designed, and then this updated version, these modifications were made by Mark Alexander, my partner from Freetronics. And I'll open this one up, and I might see if I can find examples of both of these boards, so you can see the clever little mechanical trick that Mark did with this version of the board. So I'm going to go for a walk around the room. I'll probably do that a little bit. See what I can find. Ah, no, my shields box is probably where I'll find something. Here's one of them, and yeah, that's probably enough. It's just the new one. So the old version of the shield had the module sitting right up on top of the board. I'm going to go to the document camera here. So it's looking down onto the design. So this is the actual physical product that came out of that design. Now in the first version, this module was sitting up on top of the board, and these headers were soldered directly down into it in the way you would expect. And the shield ends up coming up very high. The front of the board, if you're looking at it like this, would have come out to about here because of this big module sitting on top of the PCB. So what Mark very cleverly did was mount the module from the bottom of the PCB and did a routed cutout so that the face of it could come through. It's a bit of an odd shape. You can see that it's got this big notch on the side here. And then the pin headers are soldered straight through with no plastic spacer. Now, I'll see if I can get it up closer to the camera and get some focus. But no, it doesn't really want to focus at that distance. So they are pin headers, but there's no plastic at all. It's just two PCBs jammed up hard against each other, and the pins fed through, soldered, and then cut off. So that's kind of an interesting idea. I quite like that. I like looking at designs like this and getting inspiration for thinking about the design of a board in 3 dimensions. And that becomes really important when you are designing to fit into a case, or maybe you've got sensors that are physically bulky. When you're first designing PCBs, a lot of what you do is you're thinking about the PCB as 2-dimensional. So it's just a flat board and you're putting parts on top of it. But looking at designs like this, you need to think more in a 3D sort of way. So I found that interesting anyway. Hang on. Before I go on any further, I just saw a comment in here. Good to see you back, but it's 1:12 AM here and I'm dead tired, preparing for heart surgery Monday. What? Well, Jesper, good luck for the heart surgery. I don't know whether that means you're the one performing the surgery or you're having the surgery performed on you, but whichever way, I hope it goes well. So yeah, and get some sleep. Back to this design, and what have I got here? Names. Okay, that'll do. I'll just hit the rat's nest on there so that we can see. And on this design, you can see that we've got this big section in the middle where the routed cutout is put in. So there's a border that's defined around here. And then at the factory, the PCB is manufactured as normal, and as part of the process, they run a router around the inside of this line to cut out the hole that allows that display to poke through from the back. And then it's got mounting holes in here for the screws. And oh yeah, one other nice thing on here, and you can see that this was a bit of a transition design. This version of the design used through-hole buttons. Actually, no. I remember what happened now. This design went entirely surface mount, and you can see all the surface mount resistors down here because this was no longer being sold as a kit. But what we found was that the little surface mount buttons on here would break off really easily. And you've probably seen those little gold colored surface mount buttons, and they're okay if they are within some kind of a physical container, so it's mechanically constrained and all you're doing is pushing down on the stalk of the button or the stem of the button. But if the whole button is exposed, and in this case it's in a situation where someone is holding the board, in fact you can see it on here, I'll use this camera for now. Oh, there it is. So these buttons are exposed on the board. If someone is using that, what they'll be doing is holding the Arduino or just pushing it on a bench surface, and these buttons can flop around and they break off. So what happened was that we ended up with a number of warranty claims of people saying these had failed, the buttons had ripped off, and for a while it became a fairly regular thing that I was either sending out replacement boards or putting a few little buttons in an envelope and sending it to people because they said, oh, I'll just replace the buttons myself, but where do I get them? And these buttons are worth about 5 cents each, so I just post a few. It costs more for the envelope than the buttons. But what I did then was update the design again and go back to through-hole buttons for the control switches here. So these bits that you can see here, in this version of the design which I've got open, are through-hole. So that, just in passing, I should not get bogged down in these sorts of things right now. It just made me realize that I should talk about versioning, and what I do with all of my projects is maintain all of the design files in Git. So whenever there is any change to the design, I commit the changes and we keep a record of it. So you can look back through the repository for the project and you can roll back all the design files. So I could go back, for example, to the version that had these surface mount buttons on it and see the exact design as it existed in that point in time. One other thing, on this design you'll see that there is some documentation right on the front here. Now this is something that it's a really useful principle. There was something that Mark said to me many years ago when we were starting Freetronics, and he said the principle is, if someone is using your device and they have to go to a data sheet to look up information, then you failed. You need to make sure that if someone has the board, say someone has this board in their hands and they want to plug it into their Arduino and use it, and then load up some software to run on it. Now, because different PCBs or different boards might have different pinouts, it can be a real pain if you get a board and you might know, for example, that this uses the liquid crystal library, but you don't know what the pin assignments are for all of the select pins and the data pins and that sort of thing. And what a lot of people do is they will go to the extent of documenting the pins. So they'll say, select is D4 or whatever. So then in your program, you have to do this little match-up jig where you put in the line, like the initialization line, to talk to the device. And then you see, the first argument is the select line. So now I've got to look up the select line, and that's D4. So I'll put D4 into that argument when I write my code. What's really nice is just literally put the code straight on the PCB, so you don't even have to look it up. So in this case, it just says init string liquid crystal LCD 894567, and that's it. You just type that into your sketch and it will work. So yeah, documentation on the PCB, it's a good thing. And what else? I think that's about it. Just responding to a couple of comments. Firstly, will I make a 4-line version? Probably not, because these little character-based LCDs were popular for a while, and I haven't actually really used one myself in a project for a long time. They've really been taken over by OLEDs and things that are more like a matrix addressing system rather than a character addressing system. And that can be useful because with something like a very small OLED, you can use small fonts, or you can have different size fonts and fit more information on the screen. These are kind of retro now, I suppose, in some ways. It's almost like, it's getting to be like Nixie Tube, just like, the old style character LCDs. So I've used 20x4 LCDs on quite a few projects, but I probably won't make one as a shield. I did actually lay out a shield with the 20x4 on it, and I never released it because it was physically quite bulky, and I just didn't think there would be that much interest in it. So another comment, you may need to change as GitHub. So this is in relation to my comment about maintaining versioning of project files. And the comment is, you may need to change that, John, as GitHub is being taken over. Yes, I saw the news that Microsoft has bought GitHub, and I don't actually have a position on that at the moment. A couple of years ago, I would have said that was a disaster. Now, I think it might be okay. We'll just have to see what happens. They have an interesting history in terms of how they treat companies that they acquire and what they do with the technology. So it might be that it works out well. I know a few people that work at Microsoft, and they're really good people. Microsoft has been hiring a lot out of the open source community over the last few years. So it's interesting now if you go to, say, LinuxConf, which is the big open source conference here each year. A few years ago, there was a controversy because Microsoft wanted to sponsor the conference, and there was a big backlash against it. And over time, each year that you go to the conference now, there are more and more people that have been going to the conference for years, and they're hardcore open source people who say, oh yeah, I'm working at Microsoft now. And in some ways it's a bit of a head spin, but I think that what's happening is that to some extent the company is changing from the inside. But one thing I really like about Git in general is that because each repo is self-contained. So if you have a repository that has all of your history, so you've got a repository on your computer of your design files, and then you mirror that on GitHub or some other file sharing service. Oh, hello, Tommy's come in. You can come in, but we're on a live stream right now. Want to wave to everybody? No, yes. Tommy's come in to use the PlayStation. So, so the thing is that if you use a service like GitHub, it really is just a hosting service. It's not that they manage all of your repos for you, although they do provide tools to make repo management easier. What they're really doing is essentially providing a place that you can share it, but you can have your repos mirrored in multiple locations, you can share them yourself. There are lots of different things you can do. So in terms of potential problems that it might cause, I'm not too worried because everything is local on my computer anyway. I can mirror it wherever I want. And there's GitLab and other places as well. Anyway, back to the design. So let's see, what's next? I can't believe that I'm only on to the second project. Where are we? Eagle and, oh yeah, this one. This is a tiny little thing that I won't really even go into in detail, except that there's kind of an interesting backstory to it. This is an absolutely trivial little board, and you might even wonder why anyone would bother. This is part of the design for ArduSat, which is the Arduino-based satellite that I was involved with. And one of the we made a couple of mistakes early on with the design. One of them is that we used, there's a GPS module that is built into the satellite. Now GPS for satellites is interesting because there are all sorts of restrictions on what you can use GPS for. And if you, and the actual GPS constellation is controlled by the US military. And they still consider that GPS is a weapon system. It's used for guidance systems in missiles and fighter aircraft and that sort of thing. So what happens is that if you have a GPS module that travels higher than a certain altitude or greater than a certain speed, it will shut down and refuse to start giving output. And that limitation is built into the module itself. There's nothing external that understands that there is a receiver that is, moving high and fast, and it could be used, like a homemade missile or something. So there's no way externally for the GPS system to detect it and restrict its signal, because GPS modules are receive only. But the modules themselves can only be sold if their firmware complies with certain restrictions. And the restrictions include not allowed to give output if it's going above a certain speed or above a certain altitude. So when you put a GPS system, a GPS receiver, into a satellite which is traveling in low Earth orbit at 28,000 kilometers an hour or whatever it is, the GPS just won't work. The only way to do it is to get special GPS modules, which access to them is controlled by the US military. And you have to go through like a whole chain of custody thing where you apply for one of these modules or however many you need. And typically what will happen is that you'll get a couple of modules. You'll get, say, one for your flight hardware, and then another one which is electronically identical, but the firmware has the restriction in it, which you use for your ground-based mock-up of the hardware. And what you have to do is have a chain of custody that shows that you have taken that unrestricted GPS module and either destroyed it, returned it, or it has gone into space and it's irretrievable, so it's burned up on re-entry or something. Because they want to make absolutely sure that there are no unrestricted GPS modules out there in the wild and that people could be using for whatever purpose they like. So anyway, that's a whole lot of kind of backstory. What happened is that the GPS modules that went into ArduSat X and ArduSat 1 required which way around was it? I'm trying to remember now. They required a 5 volt and a 3.3 volt power rail, and based on the design, our assumption was that you could power cycle the GPS module simply by turning off the 5 volt rail, I think it was. Or one way around, I can't remember. And what happened was that we made this connector that was on the base of the payload for the GPS module to attach to. And it turned out that we weren't power cycling the correct power rail, which meant that we did not have software control over the GPS module to reboot it, which is necessary. And also we needed to be able to power it down in certain situations. So what this module is, this tiny little thing, is just an ATG801, which is a software-controlled switch. And it connected in series with the regular connector that was going to the GPS, so that we could, when one of the power rails cycled, it would also cycle the other power rail. And that's all it is. It's very, very simple. It's just a power rail switch controlled by the other power rail. And this little thing here, and it's very small, so it was just fixed with a couple of cables and mechanically mounted inside the chassis. So it was an inline power switch for a satellite GPS system. Nothing more than that. Okay, let's see what's next. AntBrain. Okay, oh, this is cool. This is one that I've been working on just recently. And I'll start with the schematic. So the backstory to this is that here in Melbourne, there is a combat robot league which has fairly recently started to get a bit of activity again after not much happening for many years. And they have a number of different weight classes. So the smallest weight class, I think, is called the ant weight, which has a 150 gram weight limit. So the robots themselves are tiny. They're, where's the camera? There, they're really small. And every gram matters. And the way these little robots are normally controlled is that typically they'll have something like an Arduino Nano inside them connected to a radio receiver. And it decodes PPM signals coming from the radio receiver. And then it might have like a couple of external H-bridge modules which it uses to control drive motors. It'll have something to control a weapon. There will be a power supply system, so you've got a battery in it, and there'll be a voltage regulator. And all of these things are typically discrete modules which are all wired together in this little bowl of spaghetti inside this tiny little robot. And that results in two things. Firstly, extra weight, because you've got a whole lot of different modules connected together. And secondly, unreliability, because when it's in this little robot, which might be bashing around and being thrown and knocked by the opponent's weapon, you get things like wires breaking very easily. So if you've got little hookup wires, and these are typically built by kids or students, so the assembly may not be the best, held together a bit with blue tack. So what I did was design a little combat robot controller, and the idea was to take the different parts of a normal control system, which are normally all separate modules, and put them all on a single board and make it as compact and robust as possible. And that's what this design is. So there are a couple of major parts. There's a power supply here. It connects to a LiPo battery, and I'll zoom in because the resolution is probably not the best when you're watching this on YouTube. The power supply up here, there's a LiPo battery that connects to it, and then there's just a power switch. And there's a jumper on here, so you can have an external power switch if you want to, and a couple of options for linear voltage regulators. Now, there is an interesting thing here. You can see that there are two voltage regulators, and it looks like I've messed up and put two regulators in parallel. So the inputs to the regulators, you can see both go to the same place, and the outputs are both wired together, and the adjuster, the ground lines, are both wired together. So it looks like what I've done is short-circuited two voltage regulators, and that might blow your mind, but I will show you why in just a second when we look at the PCB. And then there's a power LED just to show you that it's on. Now over on this side we have the microcontroller, so it's an ATmega 328P. Now in these little robots, it's typically done with something like an Arduino Nano, which I think is a 328, and I wanted to make sure that this was compatible with what people normally do. So if someone's used to building an ant-weight robot and they use an Arduino to control it, I wanted them to just be able to use their existing code. So I put a 328 on it, and there is a header. I didn't bother with the USB interface. I just put like an FTDI type header on here, and crystal and reset circuit. All the usual stuff, nothing too exciting there. So just down here, there are a pair of H-bridges. These are L9110 H-bridges. They're quite small, very low power. I think they're only rated to 300 milliamps or something. So they're certainly nothing that you would use in any sort of significant robot. But for a little thing like this, where they've got tiny little DC motors for the drive wheels, they're perfect because they're only pulling like 50 milliamps or 80 milliamps through those. And what you can see here is the raw battery connection. So VBAT is supplied to the H-bridges. And just as a very brief explanation, without going into the details, an H-bridge is a system that allows you to control a motor so that you can regulate its speed and direction. So a motor has, a typical DC motor has two connections, which you can see down here. and if you apply, positive voltage polarized one way, it'll spin one way. Reverse polarity, it spins the other. An H-bridge is just like a little magic thing. I can explain it in detail some other time, but it's basically just a way of controlling the polarity of the power that's applied to the motor and allowing you to regulate how much power goes to it using pulse width modulation. So what we have is the power to the motors is taken raw from the battery. It doesn't go through the voltage regulator, and because these are normally 2S LiPos, which is like 7 volts nominal or whatever, that works out just fine. So we have 2 control pins to each of the H-bridges. So we've just got left and right H-bridges for the 2 things there. We have an ICSP header so that we can reflash the ATmega. Flipper servo, so there's just a connection here to control a servo, and on this particular design the idea is that the servo is used as a weapon. Well, the servo is used to control a weapon, and if you wanted to, this is really just a digital pin, so you could just as easily use this to control, say, a MOSFET to make a motor spin or do something. If you had a much more elaborate weapon, it's just a digital output, so you can do whatever you like with it, but I've set it up as a servo header. Some decoupling caps, and down here a fly sky receiver. So this is one of the other interesting things we'll see once we get to the PCB part of the design. You can see that there is a 4-way connector here which has got A0 through A3, and that's analog inputs, I think it is. It's which pins? Yeah, A0 through A3. There are analog inputs on the ATmega, but you can also use them as digital inputs. I'm just using them as digital inputs purely for routing purposes. I picked those specific pins. And then we've got a power and a ground connection. And this is where a fly sky receiver is mounted directly on the board. So if we switch over to the board design, I'll pause for a second for some questions. So Sean Williams said, have a client that wants to use Sonoff in a kitchen factory but doesn't like Wi-Fi. Is there a wired equivalent or a way to hack together a wired version of the Sonoff? In terms of an actual official Sonoff, there is not, but it's very easy to do something that is functionally equivalent without using Sonoff hardware, or by using some other type of controller. So in my own house, for example, I have the output channels mostly hardwired. I do have some Sonoffs, but most of my output channels are hardwired using relays mounted in the switchboard. So, and I've done quite a few videos about that sort of architecture. So in fact, while I am here, I'm going to drop in a URL for people that are interested in other things. So this is a list of episodes so far, and if you want to look at how I've hardwired most of the lights and other things in my house without using Sonoffs, if you look back at, where are we? Going backwards, episode 24, Home Automation System Architecture. That's probably a fairly good explanation. It shows all the different parts of my system and how they link together, including hardwired control of most things. And then if you go back through the history of the episodes, there are some others as well that talk about how my switchboards work. So I do use I do use Sonoffs for some things for convenience. I do use a bit of Wi-Fi, but I've also tried to hardwire things where possible. That's a whole other conversation that's been had before. Robert Ellis said, morning from Melbourne, have you thought about a public catch-up? Yes, I'd like to do that. That would be cool. There are, well, I suppose there's not much more to it than that. I'd like to organise that sometime. So, hang on, there's a Robert Ellis. I used to know a Robert Ellis many years ago, who I haven't seen back when I was doing web development. So I don't know if you're the same Robert Ellis, but if you are, hi. So Cheat1995 said, have you tried KiCad or just using Eagle? Do you have the same cursor redraw issue on me like on Mac like me on Ubuntu? I have used KiCad. So I've used actually quite a few different programs for PCB design. And I first did PCB design, how long ago? It would have been 29 years ago, I think. And I've been doing it intermittently ever since, 29 years. So I've used quite a few different bits of software over that period. I've used KiCad to the extent that I can poke around in projects on it and make little modifications and things. But in terms of efficiency, because I've just spent so many hours working on Eagle over the last few years, right now that is my optimum tool because I can whip things up really fast. I could do a project in KiCad, but it would probably take me a whole lot longer. So, and other programs I've used as well, like Altium and a few others. Excuse me. So, okay, back to this ant brain, and there were two things in here in particular that are interesting from a PCB design perspective. I'll just rat's nest this to maybe hide the back layer, hide back place anyway, just to make it a little bit easier to see what's going on. Oh, and have I had the cursor redraw issue? I used to, but I haven't seen it recently. What would happen, for those that don't know, I'm not sure if this is actually the same symptom as Cheat1995 is saying. And 29 years, how old are you? I'm about to turn 48. So, well, maybe I look younger than I am. And I started doing this when I was a teenager. So, in terms of the cursor redraw issue, what happens is, because of the resolution, it's probably quite hard to see, but you can see that I'm moving the cursor around, and I've got the big crosshair cursors set up. You can see that I'm moving the cursor around near the top left part of the board. And what happens is, when you grab something or you're moving around, sometimes the cursor would vanish or it would get stuck, and what I would have to do is move the cursor, so I couldn't see what I was doing basically. So what you have to do is move your cursor, which you can't see anymore, way off the screen, and then move it back again, and then maybe you get your actual cursor visual updates happening. And it's really annoying when it happens. So it's not limited to just Ubuntu, that is a problem on Mac as well. But I haven't seen it really recently. Maybe it's been fixed, I don't know. All PCB CAD programs are evil. One day someone will develop something intuitive, but I'm not going to try holding my breath. Yes. That was a comment from Scott Miller. Yeah. I don't really know why, but for some reason PCB design is one of those things where there is this paradigm, I think, that follows on from the history of the way PCBs have been designed back before the software tools were really prevalent. And in some ways we're kind of stuck in a mental model of how to go about it, which has forced the tools to comply with that mental model, which has then made them probably more complex than they need to be. Have you tried KiCad yet? Yes, I answered that one earlier. I've used that. Okay, so the Cheat1995 said, no, I had the issue when you're in the circuit designer, it draws the grid on the first position and draws the cursor in the next grid position, and these crosses stay until you click the right mouse button or click in the menu. That's interesting. I haven't seen that particular bug before. I do run Eagle on Ubuntu as well. So my bottom row of monitors is Mac OS. My second row of monitors is Ubuntu. And it's reasonably common for me to open a project, say up on the second row of monitors, so that I can have it open for reference purposes while I'm working on something else on the bottom. And that's running Ubuntu. But I can't say that I've seen that particular bug. That's interesting. So the two things that I mentioned, I'll try to get back to this. The first thing I mentioned was that in the schematic, it looks like I've screwed up because there are two voltage regulators, and they're doing the same thing. Now this is, when you see what it is, you'll go, oh yeah, that's not actually that interesting at all. But anyway, let's have a look at this. So down here we can see the voltage regulators. So I'll just grab one of them, and you can see that here is one of the small voltage regulators, which is in a SOT89 package. I'm just dragging it around so you can see it. And I'll dump it off over here. And here is another voltage regulator, which is in a SOT223 package, and it's physically bigger. Now these are just two variations of the LD1117 voltage regulator, which is available in multiple packages. And for whatever reason, over the years, I've ended up with stock of both types of voltage regulator, and sometimes it's easy to buy one, sometimes it's easy to buy the other. So this is just a little trick where you stick footprints for both of them on your design, and you only populate one. So in this particular case on the PCB, just because of the geometry of the way those two footprints work, if I'll just hit undo a couple of times now and drop it back. So you can see that there is the small SOT89 footprint in the middle, and they are perfectly aligned. It just works out that if you put the 0 point for these two footprints directly over each other, then the pins line up, because ground and the output and the input are in the same place. The tab is the same electrically. So if you overlay them and then just link up the air wires, you end up with a dual footprint that allows you to put down either the SOT89 or the SOT223 in the exact same place, and either of them will work. And that is all. But that was the reason for doing it. I'm just going to grab this PCB. It's around here somewhere, I think. You won't be able to see me now, but you can watch Tommy playing PlayStation while I try to find this PCB. I thought it was in a box that was nearby, but maybe it's not. There, no. I have many boxes full of lots of different things, and I took them away with me when I went and visited a friend a couple of days ago. So I don't know where those boxes have ended up. So the other part of it, it's a pity I can't find it, because this next bit that I'm going to show you here, it's really helpful to look at the actual physical board to understand what's going on. You can see here that there is the ATmega 328, so that's the main processor, and then this rectangle across the top is the FlySky radio receiver. So when the little combat robots are being driven around, usually, and the thing is that saying it's a robot is not really technically correct, because they're not making decisions on their own. It's really just like a remote control toy, ultimately. So the person that's driving it will have a radio remote control that they are using with joysticks, and they're driving the robot around and activating the weapon and doing that sort of thing. So the robot needs a radio receiver to be able to get the commands. And this footprint here, well, it's not really a footprint, I just laid it out so that it would physically fit, is where a radio receiver is soldered directly onto the top of the PCB. And what happens is that I assembled the base PCB with all of these parts, including the processor that you can see there. And there is the crystal for the processor. And then this little FlySky radio receiver sits on a couple of pin headers. So you can see the 4 pin headers here. These are the 4 output channels. It's a 4-channel radio receiver. And each of those outputs goes to one of the pins on the ATmega. And if you look at the design here, you can see why I picked A0 through A3 as my pins, because it means that routing just goes straight from the header to the processor. Makes it really super simple. And then there is a power connection for the receiver and a ground connection. So the radio receiver gets the commands from whoever is driving the robot, and the outputs for the 4 different channels will come through on these 4 pins, and then they go into the microcontroller, which is running firmware that decodes the PWM signal, and from that it can get the position of the joysticks on the controller, and then you can drive the robot appropriately. So it changes the speed on the it changes the H-bridge settings and drives it and activates the weapon, does all of that sort of thing. So that's just how it gets the signal. But once this is actually assembled, it's a very compact little design. So this board is 36 millimeters by 36 millimeters, so small. And I actually picked that size just because it's the same dimensions as like a flight controller typically for a quadcopter. And I just went with the same outline. And then the radio receiver is sandwiched on top of it, and it's just spaced by the little plastic spaces on the pin headers. So the main PCB floats, the receiver PCB floats just above the microcontroller. And the result is quite a compact little control board with everything in it. So with this board in the robot, all you have to do is connect up power and the H-bridges to the motors and whatever weapon you've got, and basically that's it. It's a very small amount of wiring, and everything is self-contained. It becomes quite robust. Questions. Back to questions. Do you ever etch prototype boards at home? How long does it normally take to receive your boards? Okay, that's a great process question. I have etched many prototype boards at home, but not for quite a long time. I still have the gear here. I've got a plastic tub up there with the etchant and all of the other stuff. And I also have experimented a little bit with using my CNC machine for cutting out tracks. But and a few years ago, I think that made more sense than it does now, because it's now possible to get like a little pack of boards done on like 2-day turnaround and then DHL to you for like $20 total, including shipping. And you'll get boards that are they've got silkscreen on them and solder mask and all of those things, and the fires are put in, so you don't need to worry about putting jumpers between different sides of the board. If you absolutely needed a one-off PCB and it was reasonably simple and you had to have it like today, then etching your own board or cutting it out on a CNC mill is a good way to do it. It's basically the only way to do it, but you don't get a whole lot of the benefits of a board that's been made in a factory. And for $20 and waiting a few days, I just get them made now. It's not worth doing anything else. And also because I tend to be working on many different projects at once, what will happen is that I'll get a board to the stage where I need to send it off for fabrication, and I'll send off the design files, but I've got like a queue of other boards to work on as well, so I'll send it off and then forget about it. And then a week later I'll get a package with the boards in it, and I'll go, oh, that's right, that was that design I sent off, and then I'll start working on that again. So I interleave a whole lot of projects. Right now I've got boards queued up to assemble, so the only reason I would do it, as I said, would be timing, if I absolutely had to do one right now. So Still using OpenHab? Any thoughts about Home Assistant? Short answer is yes, I am still using OpenHab. My only thoughts about Home Assistant are that I would like to try it. So I don't have Home Assistant running at the moment, and I'd really like to. I'd really like to install it and experiment with it. I've got a few different things. I'm also using Node-RED. So at the moment I'm using OpenHab and Node-RED essentially bound together. Node-RED is providing extra rules, and I now have, so I'm slowly deprecating my own rules engine in favor of Node-RED. And of course you can do everything in Node-RED without even needing OpenHab, but I'm just using different things connected together to do the things that they are strongest at. And OpenHab seems to be quite strong in terms of user interface. It's good in terms of the app that runs across multiple platforms, and Node-RED is good in terms of the rules that you can do. So combining the two gives you different strengths. Where do you get your parts? James Lee asks. I get them from a few different places. For prototyping and my own little projects, I typically just go onto AliExpress or wherever and order them and wait for the slow Chinese shipping unless I'm willing to pay a lot of money for it. Because I've worked on so many projects over the years, I've got a pretty big parts library. Like, I'll show you something. So, just as an example, this is reels of parts from pick and place machines, and these are just the common parts that you use. What I find is that, and I think what is pretty standard, when you're doing a design, there's normally one or two hero parts. So there'll be things like a microcontroller or a sensor or something that you don't necessarily have, buckets of them. And then there are a whole lot of jelly bean parts. There are things like 1K resistors that you use in every single project, and 10K, and LEDs, and all of those sorts of standard things. And because I've built up stock of those over time, I've got reels of literally thousands or multiple reels of most of the really common parts. And then for something that's unusual that I might need, I'll just order it, wait for it to arrive. So that's just for like low volume and prototyping. For higher volume, so the boards that I have made, so at the moment pretty much all of the volume manufacturing I do is run out of factories in and around Beijing. Which might sound a bit strange considering that Shenzhen is really the manufacturing center, but that's partly a historical thing as well. So I have a good relationship with an assembly house in Beijing, and worked on many projects with them, and so I just continue to use them. So, okay, which manufacturer do you use for your PCBs? That varies. For the sorts of projects that I'm talking about in the context of Superhouse, it's mostly hobby projects, so I don't need large volumes. It's normal for me to order 10 of something, or maybe 20 or 30 of a particular board design. And usually I use all PCB in, or PCB-Way, or there are a few others. There's dirty PCBs, just for small run boards. I think I did a check recently, and I've done, I think it's something like 4,000 PCBs using short run services in the last 4 years. Like, it's some ridiculous number, because I keep a spreadsheet listing every single PCB design that I send off for fabrication, and when I ordered it, who I ordered it from, what the quantity was, what the version of the PCB was, and all of those sorts of things. And I keep a snapshot of each set of Gerbers. So when I place an order, I send off a zip file which has got all of the design files in it, and I keep every one of those zip files, and they're all versioned. So if I ever want to see, for example, what exact Gerbers did I use to manufacture version 1.1 of that PCB 3 years ago, then I can just open it and I've got everything right there. So yeah, and dirty PCBs I've used a fair bit as well. But for volume, which is basically Freetronics, because SuperHouse doesn't really do much in the way of volume. And with SuperHouse I might make 50 or 100 of a board. I don't really do anything much more than that. For Freetronics, where it's quite normal to do runs at 500 or 1,000 or a couple of thousand of a board, then that's done by companies around Beijing, as I mentioned earlier. The other companies I think are all based in Shenzhen. I kind of got off the subject of the board designs, just answering questions, but there are some interesting questions here. When you have a board fabricated, do you ever have them pre-populated with SMD components? Short answer is yes, because I get that done in factories in China when I'm doing actual proper production. When I'm doing it for my own purposes, I just do it myself. So if I'm just wanting to make a few of a board for my own projects, then I'll just order the bare PCBs and I fit the parts myself. If I'm doing a board, like a run of ATmegas or something, then I'm not going to assemble those myself. So those are all done in factories, and they're fully assembled. So to the extent that they take care of all of the testing, so I design test fixtures. They then use the test fixtures in the factory and then do firmware loading. They do all of the packaging. So by the time I get it back, here's an example. Oh, here's one that's kind of smashed up. The box has been opened. Hang on, I'll switch cameras again. Let's see if this is a better way to do it. So this is, what is it? It's an ether. This is a broken ether duet. So when I actually receive it, it's fully packaged, and this one is busted, which is why it was sitting up on my bench there. But essentially I get it like this, fully retail packaged. So this package was all done to our design. It's custom plastics that are injection molded, and so I don't just get back a blank board, I actually get a retail ready product. So these plastics are all manufactured for us, and it's packaged there in the box with everything else. And then they arrive in big boxes and get shipped out to everybody. So, okay, I'll try and catch up. I'll go quicker through the questions. Node-RED has home assistant support. I'm using Home Assistant here. Looked at OpenHab and the rule set just confused me. Ryan Davies was that comment. Yes, you're right. One thing that I really, really don't like about OpenHab is the rules engine. The language that it uses I find horrible, and particularly in the early versions. I think in the current version this isn't such a problem. Every time you edit one of the rules files, OpenHab does a full reload of its configuration, including executing all of its rules and everything. So when you are working on changing rules or tuning the system, if there's anybody else in the house at the time, it's really annoying because all the lights keep turning off and crazy stuff happens. So it really limits you to editing the rules when there's nobody else interacting with the system. And that is why I mostly use OpenHab just for its user interface and for maintaining the state of all of the devices. And then I use other systems for running the rules. But yeah, I feel your pain. What is your soldering setup for SMD? I have, as you can see in the background here, a microscope. Hang on, I'll switch cameras again. I'm at camera back to full screen. So you can see here a microscope, and just back behind it there is a PCB preheater. I've got hot air just here, and a couple of soldering irons with different tips and things. stuff falling on my head. So for hand assembly I do that, and right here there's a little tube of solder paste. So I just use this to apply solder paste to the board. This is normally what I use just for really low volume and one-off sort of projects. Basically I'll get a blank board, chuck it under the microscope, use the solder paste dispenser to put solder paste on the individual pads, and then normally I run it through a reflow oven and then I can either use hot air or a soldering iron to reflow it. So I will switch to another view. I'm going to switch cameras again and then point it around. Document camera. Okay, I wasn't intending to do this, but well, just there you can see my little homemade pick and place machine with a few other things sitting on it. That grey box that's back up behind it, that is a reflow oven. So normally what happens is that I'll put the parts on the board under the microscope and then chuck them in the reflow oven. And I've used that for, I think I've run about 3,000 PCBs through that now. I've had it for that particular oven, I've had it for a little while. I did a video about that, and you can see just behind that is the black box is my laser cutter. It's got a drone sitting on top of it at the moment, and then you can't really see it, but back behind that is a CNC machine. So another view of the workbench down here. I should do a better explanation of the workbench at some point. For now, I'm just going to stick this camera back, pointing back down there. Okay. What's your thought of Sonoff ever meeting Oz standards? Yeah, that's a subject that makes me scream. I don't want to get into that right now. To be honest, that's a big topic that's buzzing around in my head. And Ryan Davies says, I want to install Sonoffs in my house, but all the switches are 2-wire. Yes, that's a problem. If you don't have neutral available, then it can be a real problem putting the Sonoff in place where the switch is, because you need neutral in order to power it. And I really want to cover that sort of thing in a future video as well. Let me see, back to here. So, just before the lights, oh yeah, so Toby Robb says, place the Sonoff just before the light fitting and leave the switch on. Yes, or even isolate the switch entirely, or use the switch as a logical input to the Sonoff, so you can still walk up to it and flick the switch and then have the Sonoff change the state of the output. That's the sort of thing that I want to talk about in one of the future videos. Okay. So, slam for maybe an option if you're renting. Yep. Another suggestion from Toby. That is a device. In fact, I have one right here, because I was just in the process of filming an episode of Superhouse about how to reflash Sonoffs. I've got a whole pile of Sonoffs here, and I'm going to go through every one of them and show where the headers are and what you need to do. So that is a slamfer. What you do is unscrew your normal light globe and you screw this in its place, and then you screw your light fitting into it, and then you have Wi-Fi control of your lights and no other rewiring required. Yes, be nice if they provided slamfers in bayonet instead of just screws. Yes, that is true. Oh, James O'Gorman said, have to run and eat. Well, thanks for hanging around, James. Go and eat. And he said, don't forget to plug the Superhouse forum. So, if you, what is the, that's embarrassing, I click on the link. Is it forum.superhouse or is it discuss. I think it's discuss.superhouse. Superhouse SuperHouse.tv. Let's see if this works. No. This is terrible. I don't know the URL for my own forum. So it is discourse.superhouse.tv. I will drop it in here, and I really need to spend more time paying attention to the forum. Sorry about that. Okay, so Goose and P said, when you apply solder paste, do you use a stencil? If so, do you use your laser cutter to make them? Great question. So for small run boards, what I normally do is just use the little syringe thing to apply it on just per pad. Of course, that's a pain if you want to do more than a few boards. It takes a long time. So it might take you a few minutes per board to do each of the pads individually versus using a stencil where you can do a board in 15 seconds. Just lay the stencil down, wipe it over, and away you go. The answer is I actually do both, depending on the project. So just to show what we're talking about, here are some stencils. Okay, here is the stencil for the Ether 10, which is a board that many of you will know. Got to try to get the position correct. It's a thin piece of steel, and it has been cut so that there are holes where all of the pads go. You lay this down on top of the PCB and then use essentially a squeegee to wipe solder paste across it. It's like screen printing, and then there's a little bit of solder placed in each of the locations where there's a hole. So then you just lift this up, lift it up carefully so you don't smear the solder paste, take the board away and put another one in, put this down, do it again. So with a stencil like this, you can do boards very quickly. And I've actually got quite a pile of little stencils here, and there are more stencils. I think there are some Mylar ones in here. Yes. So these ones are steel, and the steel stencils last longer, but they cost more. And you can also get stencils made of plastic. So same sort of thing, it's just that it's plastic. So over time, with abrasion, the edges of the little apertures start to get a little bit worn. So these are good for like 100 boards, maybe, that sort of thing. Whereas a steel stencil, you can do thousands of boards and it won't wear out for a very long time. The plastic ones are cheaper. And in terms of, do I use my laser cutters to make these? No, I haven't actually. So my laser cutter I normally use with just thicker bits of plastic. I don't normally use it with this sort of thing. And it's not powerful enough to be able to cut steel. It's only a 40-watt laser. So I normally just get these done at somewhere like, somewhere like Dirty PCBs. Most PCB houses now, the places where you can order online, if you order a board, in a lot of cases you can just tick a box and say, yes, add a stencil to the order. And they use the same Gerber files to generate the stencil. So it can cost a bit. Sometimes, the stencil might add $20 to your order, but it can save you an awful lot of time. And getting it done by the same house that does the PCB means that this is going to be very accurate. I think the quality that they get out of this with some of these very small apertures, that's a QFN chip there, I think. There's another smaller QFN down there. I think they can do a better job than I could on my laser cutter. So I just let them do it. And for the larger production runs, typically the stencils are put onto a frame, and that keeps them stretched out and rigid. And the frames are a standard size to fit into a stencil machine, like a solder paste application machine. And normally the machine has an arm, so it'll lift the stencil up, the board goes into place, the stencil comes down, it's clamped, and then there is a mechanical squeegee that moves across and it applies the paste. So it's largely automated. These don't have a frame on them, they're floppy. So what I normally do is make up a little jig. I wonder if I've got one handy. Yeah, I could pull one out. Let's see. Maybe. Yeah. I think I've got one in this box. Yeah, it looks kind of messy, but this will give you an idea of how I use these stencils. So this is a mylar stencil, so it's one of the plastic ones. So what I do is I've got a whole bunch of old PCBs which are the same thickness as the target PCB, and so what I've done is I've just stuck these down with double-sided tape, and this space in here is the exact correct dimensions to stick in the PCB that's going to be the target. So in this case it's Think PCB version 1.1, and then the stencil is just taped on there. Looks really crude, but it works. So you drop the blank PCB in there, fold the stencil down, and then use a scraper like that sort of thing. It just looks like a credit card basically. And you can get different types of scrapers. These are cheap, but you can also get metal scrapers and different types, rubber ones. And then you basically just scrape the solder paste down over the stencil, lift this up, take the PCB out, chuck it in, chuck the parts on it, put it in the reflow oven, and away you go. So, hopefully that explains how I do that part of it. Okay. I've lost track of where I am up to with the questions. C names for the win. Yes. Just have a low voltage. Yep. Okay. I'm going to ignore questions for just a second, and I'm actually over the time that I was intending to do this. Let's just have a look back at Eagle, and I'm still in the A's on these projects. I could go for days and days talking about all these different things. So AntBrain. Okay, I'm just going to cover these next couple of projects because the next three all fall into a group, and you'll understand in a second. And then I think I'm going to have to call it a day and go and get something to eat myself, and then maybe spend some time doing some proper filming on Superhouse videos. So the next one down in the list is ATTiny85 ZIF, which is a zero insertion force board. We'll go to the schematic first. So the ATTiny is a little processor, very small. It's only got a few I/O pins, but they're useful for little embedded projects and things. Part of the problem is that programming them can be annoying. So typically what happens is that you put them in a breadboard, and then you've got to put in different connections so that you can do the reflashing. And so I've got here a breakout. Essentially what this does is make it really easy to put an ATTiny processor in place and then connect up a normal FTDI. Oh no, not FTDI. I've got that too. Sorry, I was confusing myself. So I've got the ICSP header, and this is what you use for actually doing the reflashing on the processor. And up here I've also got an FTDI header for serial communications. And the idea with this is that I wanted a board where I could take an ATTiny processor, put it in, and load a bootloader onto it or load a program onto it, and then be able to communicate with it. So it's this part in the middle here where you can see it's got the ATTiny footprint. That is actually for a zero insertion force socket, and it's got a power source selection. And in this case, if you wanted to program it using the Arduino IDE, there is an Arduino core which takes care of things like setting the registers and mapping the I/O pins to labels that make sense from an Arduino point of view. So David Mellis has made a core for the ATTiny, and I just copied and pasted from his README. This is a bit of a pain to read. It looks like a big mess right there. Let's fix that. If oh, actually, I don't know if I can change that font. Font proportional. What happens if we make it fixed? Hopefully, it'll then be legible. There we go. So in his README, he's got this little pinout diagram which shows the individual pins on the ATTiny microcontroller, and then in brackets the pin name that it maps to in his board profile for the Arduino IDE. So D10, for example, you could call it D10 in Arduino. It's actually PB0, so bit 0 of the of port B, and that's on pin 2. And I just stuck that directly into the schematic. And this is another interesting thing. I like doing documentation both, as I've shown before, on the PCB and also in the schematic, so that if you are trying to understand how this schematic works and why it was done this way, you don't need to necessarily go off and look at some external reference. The explanation is right here. You can think of it as being the same as putting comments in your code. The design, you can have just raw source code with no explanation, and a lot of the time that's fine and you can read it and understand it, but it's useful sometimes to put comments in source code so that not necessarily to explain like line by line, but understand the thinking behind the reason for a certain design. And I do the same thing when I'm designing circuit boards. So you can think of this as being like a comment in the source for this design. And this is showing how the pins are mapped. So later on, if you come back to this and you're trying to figure out what's going on, you can see, oh, if I load this particular Arduino core and I reference D10, then it's port B bit 0 and it's pin 2 on the chip. So it just makes it much easier. It saves you looking up all those little individual bits of information to build the chain that that links that together. So if we now go to the board, you can see that it's got this big white section through here. This is where the zero insertion force socket goes in, reset button, and I've tried to put a big indicator down here for pin 1 because it's not so obvious on the ZIF socket which way around you need to orient the chip when you put it in. There is also the ICSP header up here, and I've got the FTDI breakout here. There's also a power select jumper, so you can say whether you want power to come from the ICSP header or from the FTDI cable. So you can put your ATTiny into the zero insertion force header. I'm going to grab the actual hardware and show you, because that probably makes more sense than looking at the design in Eagle. Now, once again, I've got to find these things. Way too many projects here. Here we go. That particular design is this board right here. And it's got the ZIF socket. So ZIF just stands for zero insertion force. It's an IC socket, but it's got a little lever on it. And inside it, it's going to be very hard to see this. I'll try to get it near the camera. It's got open sections where the pins go in, and then by pushing on the lever, it moves those little, I don't know what you call them, little feet, little legs inside, and it closes up the holes. So it means you can drop your IC into the socket, pull the lever, and now you've got it. It's locked in there and you've got a good connection, but you don't have to apply any force to it. It's hence the zero insertion force name, and it's very easy. So you drop your IC in, push down the lever, it's locked in place, then you can reflash it, and the header on this is for an ICSP programmer, and I have one of those somewhere right here. So this is just like a USB ASP type programmer. So all you have to do is plug that in, and then you can reflash or program your ATTiny. Very easy. So that particular one is for the ATTiny84 format. I've also done another one for the ATTiny85, which is a smaller size. So if we switch back to the design here, and as you can see, I've got more documentation on the PCB. So RX is PA, like port A bit 0, TX is port A bit 1, and port A bit 2 for an LED down here. So if you wanted to load blink onto your ATTiny just to check that you're able to program it correctly, you could flash that LED if you wanted to. So this is a project that I did a while ago, and I've actually never released this particular board. When was it? Let's see. 2017, March 2017, and I still haven't got around to releasing it. Which is very slack of me, because they're ready to go. As you can see, they're right here. But now if I go to Control Panel, and then back into ATTiny85, so, no, I don't want to save that. So this is another one. So I've done 3 different versions of this little style of ZIF programmer. This one is for the ATTiny45 and 85, and which are much smaller, the little 8-pin chips, and it's basically the same thing. If we go into the schematic, I've got down in the corner here, I've got the documentation of what the mapping is for those pins, and in this case, because the ATTiny85 series is even more limited than the 84 series, it's only got 8 pins, and I haven't included an FTDI header on here for serial comms, because it's almost useless for that. Something like an ATTiny 85 is a sort of device that you build in for a single purpose use. Like you might have some very specific application for it. It's only going to be doing something very limited. It's only got a couple of I/O pins. It's not usually the core of any sort of significant project. So there's not much point having something like serial communications on it. But it's just got the ICSP header, and it's got a 0 insertion force socket here, and crystal. One of the reasons that I included crystals on these is that I wanted to give flexibility, because for some projects you want to use the internal oscillator on the microcontroller, and for some projects you want an external crystal so that you've got a more accurate timing signal, and there are various other reasons. And also sometimes, this is a story that I'll get to another time when I'm talking about ArduSat. Sometimes you can screw up in a way that will essentially brick your microcontroller unless you have a proper reference clock. And I actually did that on one of the ArduSat prototypes. I bricked the main management processor and then had to recover it. So I'll tell that story some other time. But what I did was I included the crystals on there to give maximum flexibility. So if you if you are intending to use a crystal in your project, then it's there on the breakout board, which might be useful for programming. But if you don't need it, it doesn't matter. So it's one of those things where it's safe to include it, and it doesn't matter if you're not using it. So back to the board, once again, same sort of thing. Now, one of the difficulties with this board is I have not been able to find 0 insertion force sockets for 8-pin dip. The smallest ones I could find are these ones here, which are for, what is that? 14-pin. And so what I did was use just the top part of the socket, so these first 8 pins, and ignored the rest. They're just not connected to anything. And that means that on the actual physical board, it's not that obvious where you're meant to put it in, because if you've got an 8-pin dip, so this is just the 14-pin ZIF socket on its own, not mounted in a PCB, and you only want to put in 8, it's not so obvious where it ends. And so what I did was just put a bit of tape over the end, which is kind of a dodgy solution, but I couldn't come up with anything better. So hang on, I'll try to turn this around so you can see it from your point of view. Everything's backwards for me. And you put the 8-pin chip into here, and then you fold it down, and then you can use the ICSP header here and USB ASP or something, and you can flash your ATTiny. And now I'll move on to the next one, because as I said, this is a set of 3 projects that are all related to each other. And this one is actually the first one I did. I'll turn on silk screen for this one as well. This is for flashing AVR, like ATmega 328s and that sort of thing. I'll just get the schematic up and then I'll show this to you. Okay, back to here. You're familiar with this now because I've just shown you 2 more of the same sort of thing. We've got the ATmega footprint here, and once again it's a 0 insertion port socket. I've got the crystal off to the side. There's an FTDI header, so I can do serial comms, power source selection, and LED. So it's just a power LED and an LED on D13, so you can do blink just like with an Arduino. And then, oh, when was this one? This must be an old design. March 2016, so I did this one a little while ago. Back to the board. This was actually the first one I did. The versions for the ATTiny I did a little bit later. And part of the reason I did this is that I wanted to pre-program a whole bunch of ATmega 328s with the Arduino bootloader, but putting them into a breadboard or some other sort of connection is really annoying. So I came up with this breakout. Now, somewhere, where is this? I actually set this up in a sort of semi-permanent way, and I'll see if I can find it. I put it on a little laser cut base and everything, and then attached a USB ASP to it. I thought it was right here near my computer, but I can't see it. Well, just while I was looking for that, I randomly came across this other one. So this is the example of the ATTiny85, and it's actually got the chip in its place. So this is one that I was just using for some project and programming it. I am sure I've got one of these other programs somewhere. No, maybe not. Oh, hang on. Yes, here it is. And this shows something else. There's something else interesting. I've forgotten about this as well. Bit of dust. Okay, so what I did with this one is, I'll switch back to the overhead camera and see if this works any better for showing it off. I need some kind of better camera setup for this type of thing. So what you can see here is the AVR ZIF. Get that out of the way. You can see the ZIF base here. So you drop your ATmega 328 into that and then push down the lever. There's the ICSP header, So what I did was laser cut a little base and put some feet on it, and then mounted the programmer using standoffs. And then I've got the programmer here, the little USB ASP, which is stuck on using double-sided tape. Try to get the angle. So that's adhered to the base, and then I just wrapped around the ribbon cable that goes from the programmer to here. And the result is that I can just sit this down on the bench, plug in USB to my computer, and it then makes it really easy to program a whole series of them. So I can have the flashing script open on my computer. I can just put in the processor, pull down the lever, hit flash on the computer. It does its thing, flick it up, take it out, put the next one in, put it down, hit flash. So you can churn through a whole bunch of them quite quickly using something like this little time-saving contraption. Now the odd thing about this is that I've got an external button mounted on here, and it comes through to a header on the USB ASP, and that is the slow clock header. Now the reason for that, and I'll switch back over to here, I think it might actually, it's almost easier to demonstrate things on this camera than it is on the overhead camera. Now the reason for that is that when you get an AVR, typically like say an ATmega 328, the fuses are set internally that in such a way that you can't program it at full speed. You need to talk to it at a much lower clock rate. So what you do is you have to put the programmer into a mode that runs at that lower clock rate. And I find it really annoying because if you are flashing, say, the Arduino bootloader onto a 328 and you're doing it at the low clock speed, it can take a couple of minutes. It's like really frustrating, and it really should only take like 10 seconds. So one way around that is that you can put the programmer into a slow clock mode, and then instead of installing the bootloader, like flashing the whole image, what you do is just burn the fuses to set the operating mode of the processor so that it can then support the higher clock speed, and then you switch the speed of the programmer to high speed mode, and then you run the burning process for the actual image at full speed. So it means that it goes from being a one-step process to being a two-step process, but overall it ends up saving time because you can get the whole job done in like 25 seconds instead of several minutes. And that is what this little contraption here is for. There is a header on the programmer which tells it to go into slow, like low speed mode. And what I did was make up a little cable that with a socket that plugs into the header on the programmer, so that whenever this button is pressed, the programmer is in low speed mode. And this is a bit of a manual solution, but even a manual solution like this saved me a whole lot of time. So what I did was, on my computer I've got a script that operates in two stages. It first uses AVRDude in order to burn the fuses to set the high speed in the processor, and then it uses high speed to load the image. So what I do is basically I hold down this button, run the script, it changes the fuses, I let go of the button, and then it loads the Arduino bootloader, and the whole process happens much faster. Now, where I was intending to go with this, now this was a good enough solution basically for what I needed to do, because I needed to program like 30 or 40 or 50, however many it was, ATmegas. If I needed to do hundreds of them or thousands of them, that's really annoying having to sit there and press this button for each one so that it goes into the correct speed mode at the right time. So where I had been intending to go with this was make an expanded version of this that has something like an Arduino on here as well, and have that control the operating speed of the programmer so that I wouldn't need to use this button. And then it could just be done as a single thing. So what I could do is have a version of, I could even do this in software. So what I could do is use the USB programmer sketch that you can run on an Arduino, have that in place of the USB ASP, and modify it so that it starts off in low speed mode, does the fuse flashing, switches to high speed mode, and then loads the bootloader. And then I wouldn't have this manual process. I would just run the script and everything would happen magically without any human intervention each time through. So that is the reason for this. There's probably not much more interesting on that, but as you can see from those 3 projects, I've got the ATTiny84 programmer, the 85 programmer, and the AVR 28 pin. So, you know, ATmega 328 or whatever programmer. They're all a family, and they do similar things just for different boards. And if there are other processes that I need to do programmers for, I might do some variation of that. So it's now heading towards 2 hours doing this, and I'm still in A's on my project list. So I think that it's probably time to stop for now, but if people think it's interesting, I can go through more projects another time. What I could do is maybe make this a bit of a series, so come back to where I finished off and then start on the next project and see if there's anything else that's interesting, and just keep going in little segments until I run out of projects. And hang on, I've got to go back up. Just to finish off, I'm going to try to catch up on some of these questions. Okay, so where are we up to? Going way back to okay, so Toby asked, I've just been using a hot air gun, is it really worth getting an oven? It totally depends on volume. Now, there are advantages to an oven. It can do a better job in some ways. So with a hot air, with a hot air gun, the heat is very localized, and that can be really good if you're doing rework or if you're wanting to selectively solder different parts onto a board. But if you're doing a complete board, it can be really annoying. Now, part of the reason for that is that with the localized heat, you end up with a little bit of thermal stress on the board. If you use a reflow oven, what happens is that it follows a reflow profile where it warms the whole board up gradually. It doesn't just turn the power on full. It warms it up to a certain level, which is below the melting point of the solder. It depends on the profile that you are running, which depends on the solder you're using and all sorts of factors. But typically what happens is that it might bring the temperature up to, say, 120 or 130 degrees, and then it will hold it for a period of time, which might be 30 seconds or a minute. And what that does is it gives the entire board time to warm up, including all of the parts, and some of them might have more thermal mass than others. You might have some parts that are just little 0603 resistors, and they've got almost no thermal mass. But you'll have other parts that do have thermal mass. So by bringing the board temperature up gradually across the entire board and then stabilizing it, it means that things like expansion and contraction end up being much more consistent across the board. And then once that temperature is stabilized, so that's called the soak period. So it goes through a cycle which is heat, soak, spike, cool. So heats it up, soaks it, so it gets the temperature consistent all the way through the board. Then it spikes the temperature, where it raises it to a point which is high enough to melt all the solder and make it reflow on the board. And then it cools it, so the temperature then drops off. And it doesn't just turn off the temperature and make it go cold immediately. what it does is bring the temperature down at a very controlled rate. And once again, that's to reduce thermal shock to the components, because if you try to cool everything too quickly, you get contraction, and you might have things like ceramic capacitors cracking, and the board might contract at an inconsistent rate because some parts will cool down very quickly with low thermal mass, other parts might take longer to cool down. So by bringing it down in a controlled way, it avoids that sort of problem. So using a proper reflow oven with a with a reflow profile that is suited to the type of solder that you're using, it's much safer and nicer to the board than using a hot air gun. Now, I'm not saying hot air guns are bad. Hot air guns are fantastic, and I use them all the time. But if I'm going to be assembling a whole board, I always use the oven, just for convenience as well, because it means that I can load all the parts on, and then I just put it in the oven, press go, and then walk away. And the PID controller in it takes care of tracking the correct heat profile and everything. And then a few minutes later, it beeps at me and it's done. And I walk over and take the part out. I'll take the board out, and it's all sorted. So it's less work. I regularly run 20, 30, 40 PCBs at a time through the oven, and I do that just by loading them all in, press go, and a couple of minutes later, all the boards are done. So what I would really like actually is a very small reflow oven. For many years I used a pizza oven. I just went down to the local Good Guys store and bought a pizza oven. I put a thermocouple in the back of it, and I put on a controller from Rocket Scream. They do reflow oven controllers. It's just a shield that plugs into an Arduino, and then it reads from the temperature sensor and controls the output. So I had it controlling a relay which was switching power to the heating elements in the toaster oven. And then I upgraded to this bigger, sort of semi-commercial grade reflow oven a little while ago. And that's like a 2,800 watt thing. Like, it needs a big power socket, won't even go into a regular power socket. And I feel bad about running that whenever I just want to run, like, I might put a board together that's, one of those ant brain boards that's this big, and I'm running this nearly 3,000 watt oven for a few minutes just to reflow one tiny little board. What I'd really like to do is have a second oven which is small, like ideally, tiny size, just to put a single board into it or a couple of boards and reflow those. And it probably wouldn't need to be more than a couple of hundred watts. And just use that oven when I'm putting in a few boards at a time. So anyway, it comes down to what you need. So still looking for a good 110 volt LED dimmer circuit for the lighting relay box. Yes, dimming, that's a big questions. Okay, what state in Australia are you from? I am in Melbourne, Victoria. And yes, I know I say Melbourne like an American because I learnt a long time ago that dealing with an international audience, I have to do a bit of a strange accent, which is halfway between Australian and American. So I pronounce my R's more than if I was just talking to a local and saying, I'm from Melbourne. Okay, ZIF sockets are great. I have a few for surface mount ATTiny ICs as well. So that was a comment from Toby Rob. Yes, I don't actually have any here to show you, but there are the same sort of principle that I showed for the zero insertion force sockets for the dip, which has got the 2 rows of pins. You can get zero insertion force sockets for surface mount parts, and they're really cool. They're usually square and they're quite bulky, so you get this tiny little chip in the middle, and then you've got this big mechanism that sort of squeezes in from the sides. And so I have actually been thinking about maybe doing versions of these ATTiny programming boards, but for the surface mount versions of the processors. And I actually use the surface mount versions of the processors more than I use the dip style. So for me personally, it'd be more useful. And yeah, that might be a future project. They're very cool. So Seabreeze Coffee Roasters asked, what's a good source of ATTinys and ATmega processors? The sources for Atmel processors have been quite variable over the years. There was a time a couple of years ago when global supply of the ATmega 328s basically disappeared for a couple of months. There have been some times when it's been a real problem. For my own projects, I normally just AliExpress them, and I've got stock of them. You can't see it with the camera angle here, but I've got a wall of... Actually, you could if I switch cameras again. So I'll rip this camera out and turn it around. So this is the... you can't really see because of the field of view. That's the computer. And then back over on this wall, there is a wall of little drawers. And in those I've got all sorts of different things. Oh yeah, and there's some hard disks and other stuff. 3D printer in the background, you can see the light tent. And in those drawers I've got stock of a whole lot of things, including a whole bunch of ATTinys. Sorry if I'm making anybody seasick with waving the camera around like this. I'll switch back to the other one. So I've got... somewhere I have trays of ATmegas in the surface mount form factor. Right now I'm not even sure where I would look for them. They're around here somewhere. I won't keep you waiting while I look for random things. So I've got, once again, because these are the sorts of parts that I use in many different projects, I've got ATTinys in different versions. I've got ATmega 32U4s, 328s, and 1284Ps, which is a little processor that I like quite a lot, and other processors in different packages. I usually have at least a few of each of those in each of the possible packages. So if I'm just wanting to do a one-off project, I've got stuff here. For volume, so through Freetronics, because we use ATmega 328s in a lot of our products, we normally buy those, in quantities of many thousands at a time, and that's done through the part sourcing agent in Beijing. So they take care of that sort of thing. Okay. A comment from Neil about wiring up with Cat 6. So, well, good to hear. Thanks for the comment. Toby Robb said, don't forget to plug the store, John. Okay, so plugging the store. So there is an online store for Superhouse, and in fact, well, there's an online store for Superhouse and also for Freetronics. So many of you would know me from the context of Superhouse, some from the context of Freetronics, and they're two independent things, but they both have online stores. They both sell boards that I design. So if you go to SuperHouseTV, you can buy many of these little gadgets from there, and if you go to freetronics.com, you can buy many from there. So Amor asked, do I do tarot readings? The answer is no. Let's move on. And then Doug's 001 asked, do ATTiny have serial TX and RX, SPI, I2C? They typically don't have dedicated pins for those things, or they have pins that are multifunction just because of the limited pinout on them. So let me see, I'm going to switch back to here, and let's go to the project for, say, the ATTiny85. We'll load this one up, go back to the schematic, and what you can see on here is it's got MISO MOSI, which is master in slave out and master out slave in, which is used for SPI, and the clock line for SPI. And it's got D0 and D1, which are typically used for RX and TX for serial communications. And in terms of I2C, I actually don't remember. I haven't looked at the datasheet for this chip for a while, but you could do, oh, they're quite limited on memory as well. I was just thinking you could do software I2C on them, but there's not a whole lot of, of memory to play with. So I think you can do I2C off these, but off the top of my head, I just don't recall. I'd have to look up the datasheet to find out. And if you look at the pinout on the ATTiny85, you can see it's even more limited because it's only got a very small number of pins, and some of them are doubled up. For example, the reset pin is also a data pin, which is the case on other AVRs as well. But with something like the ATTiny85, because you've got such a small number of pins, by the time you take out ground and power, which you need, you've got 6 pins left. And then one of those is typically reset, so then you're left with 5 pins. And then we've got MISO, MOSI, and SCK taking up 3. And if you want a crystal, that takes 2 of your pins as well. So the most common way to use chips like this is to use the internal oscillator, not to use an external crystal, because you can't afford to lose 2 pins for a crystal. So I think you could probably do I2C off an ATTiny85, but I don't know if it's actually got the internal hardware for it. You'd probably have to just do it in software. So someone will probably correct me on that, but oh well. Without looking into the datasheet and making everybody sit around while I bore them, I can't really tell more. Oh yeah, Toby Rob says, serial is difficult but possible. Yep, exactly. Because of the lack of pins. Neil Riley suggested 3D printing a blanking socket for the ZIF so that the smaller chip doesn't go into the wrong place. Yep, that's a good idea. Dodgy Brothers said, I have no idea what you're talking about, but you make it sound fascinating. And Dodgy Brothers, I think I know that name. I might have a clue who it is. I'm not 100% sure though. I just remember someone from a long time ago who I have computer envy. Okay, where are we? I've lost where I was up to. My the comments have jumped. Ryan Davies, that mower still alive? Yes, it is. I'm going to do some more on that. I technically failed to meet my obligations. So what Ryan is talking about is the Husqvarna auto mower, so the robot lawnmower that I have driving around my backyard every day. The agreement was that Husqvarna would provide me with the mower if I did a certain number of videos about it, and I didn't meet the obligation, but they haven't ever come back to get the mower. So presumably they're okay with me keeping it, which means that I can now start to do more interesting things. Technically, the mower was on loan from them, which meant I couldn't do things like pull it apart and modify stuff. But enough time has gone by now that I think I'm fairly safe that they're not going to come back and repossess it from me, so I can add some things to it. And yeah, I want to do some more fun things with that. Okay, so there's a question here from Just For You Vacation Rental. Hi, I would like some help regarding Sonoff. This is the sort of question that I get a lot, and it's difficult for me to help individuals because there are so many questions, and so many questions get repeated as well. If someone asks me a question privately, like in DM or directly somehow, and I help them with it, I'll probably get the exact same question 4 hours later from someone else. So I'm happy to provide assistance where I can, but I can't really it doesn't scale for me to answer questions individually and provide personal help unless I'm being contracted to do it. So I'm available for contracting for what that's worth. But this is probably the right time to plug the forum again. So for people that have got specific questions about Sonoffs, like problems like how do I do a particular thing, if you raise those sorts of questions in the forums, I'll do my best to answer them, but it doesn't really scale answering questions individually. That's a strange question. About an eBay buyer accusing me of sending them a used item when it was in fact factory refurbished. He claims factory refurbished items are supposed to be packed in new packaging. Any ideas? I don't know. That's getting into consumer law stuff that I have no idea about. Okay, so Samuel wants to know why I use different pins for the ATmega for the Ethernet, pins D10, D50, 51, 52 versus D10, D11, D12 and D13. That is a very good question. So it's a question I've had a number of times. What Samuel is getting at there is when you use something like an Ethernet shield, which plugs into an Arduino and it has the Ethernet chipset and the RJ45 socket and everything else on it, the Arduino needs to communicate with it. And there are certain pins that are used for that communication. The reason is that the processor on a normal Arduino like an Uno, which is the ATmega 328, has its SPI pins used. It's got hardware support for SPI, and that is the method that's used to communicate with the processor on the shield. And on the ATmega 2560, which has a whole lot more pins than the ATmega 328, the SPI pins are in a different location. So the result is that if you have an Arduino shield, I'm thinking about an example of this. Probably got one here somewhere. Somewhere I have a box of shields. Oh yes. Oh, here's one. So this is actually one of the first ever Freetronics products, a very early one. It's an Arduino shield with a WizNet W5100 on it. There's the RJ45 socket. So this adds Ethernet support to your project. And just up along the top here, it's all backwards, so I'm trying to figure out. There we go. So D10, 11, whatever it is, 12, 13, those pins, which have got the outline around them to show that they are in use. Those are the SPI pins that are used to communicate with the, it's really confusing when it's mirrored, with the WizNet Ethernet chip. And so if you take an Ethernet shield like this, designed for an Uno, and then you plug it into a Mega type board, it won't work because SPI is on different pins. And on the Mega, there's one right here. Well, this is an ATmega, but you know, the original Arduino Mega is basically similar to this, but it doesn't have the Ethernet support on it. It's got more pins all the way down around here, and SPI is on these pins down here. So if you plug in the Ethernet shield, can't get the angle right, it doesn't even make contact with the pins down here where SPI is exposed. So what you often have to do in that sort of situation is, well, one of the solutions is that SPI is also on the ICSP header. So if you have an ICSP header on the shield and you connect that through to the ICSP header on the Arduino, you can communicate with it and it will work. But to get back to the question, because I'm kind of rambling a bit, SPI on the Mega is on pins that are down here and not up here. And so on the ATmega, the WizNet chip, which is this one, which one is it? No, it's this one. There's the WizNet chip, is connected by SPI to the main processor, which is this one up here. Hopefully that rambling explanation made sense. Okay. Snag claim. Sorry, Theft TV. I can't really help you with your questions about scam problems on eBay. Okay. Okay. Spider Eyes made an interesting comment. Mini reflow oven from a butchered hot air gun and controller circuit. That's an interesting idea. Another thing I could do, I mentioned this before, but I didn't really show it to you in detail, is this thing is a board preheater. It's basically a hot air gun in a box. So what you use this for is to bring the temperature of a PCB up to a certain level and then use a hot air gun to finish off the job. So there's a heating element in underneath and it blows hot air up through here. So what you would do is, I'll do this kind of out of sight just because I can't reach that easily. So what you do is you use the these little magnetic mounts, they slide around, and you just clip your board in place so that it's over the heating outlet. Plug this in and turn it on, and then you've got control over how much heat comes out of it. And this basically just blows hot air up from the bottom of the PCB, and it brings the whole board up to a certain temperature. Now typically the way this is used is that if you want to remove a part from a board, the problem is that you have to take the temperature of that part all the way up to the point where the solder will melt. And with a hot air gun, typically you are heating a very localized area. What this does is allow you to do almost the same thing as a reflow oven, but in an exposed way and a controlled way on your bench with the assistance of a hot air gun. So you heat the board up to the point, you don't actually get it hot enough to melt the solder. That's not the purpose of this, although I could probably do it. You set the temperature so that it brings the board up to a point where it's a bit below the melting point of the solder. And then you get your tweezers and your hot air gun and you hit the part of the board where you want to do your rework, and it only has to raise the temperature by a small amount to get it to the melting point, and then all of a sudden that part of the board liquefies and then you can move parts and pick them off or whatever. So this is really useful for doing board rework in conjunction with a hot air gun. And that idea from Spider Eyes, I hadn't actually thought of that before, but maybe something like this could be the basis for a mini reflow oven. So what I could do is take this little plate off, I wouldn't need it anymore, and essentially box this part in and put a controller in it. This doesn't have any kind of PID control at the moment, it's just like a straight turn the knob and that's how hot it is. It doesn't have any timing element or anything, but I could put a PID controller with this and use this as the basis for a mini desktop reflow oven. That's an interesting idea. Thanks for that idea, Spider Eyes. That's cool. Might think about this. Cheat 1995. You chipped yourself a while ago. Did you regret it and have it removed now, or do you still have it in your hand? What's your experience with it over time? I did. It was more than 10 years ago, I think. I'd have to look up the date, but it was a long time ago. It's still there. It's in my arm right there. I can just feel it, and I still use it. It still works. There's no battery in it. So in theory, it'll last as long as I do, and it's still useful. It's very outdated tech now. The particular one that I've got is, it's many, many years old. It doesn't have any encryption or anything. Do I regret it? No. I just wish I had a more modern version. So at some point I might need to get a new one implanted as well. Maybe if I do get another one, I could possibly get it done in my hand. But the reason I went for my arm, which is a bit of an unusual place, is that I specifically wanted to avoid the possibility of crush injuries causing damage to it. And at the time, my concern was just, for example, if I took a strike, like if you've got a little glass chip that's in here or somewhere in your hand, and it gets hit or crushed, then it could break inside your hand. And because there are bones and things here, and your hand is more likely to get that sort of injury than your arm. That was the reason. And being in my arm, it's under the skin, but just above muscle, which means that to be actually crushed and broken would take a really serious amount of trauma. So if I was going to get another one, I'm not sure where I would get it done. And because for the last few years I've been doing jiu-jitsu, I'm kind of more concerned now even than I was then about hand injuries, because your hands kind of get knocked around a bit with jiu-jitsu. So, and I've never had any problems. Like I've done many hours of training in jiu-jitsu with taking all sorts of bizarre forces and things to my body, and never had any problem with this whatsoever. So I think this has been a good place for it in general. So YB Kaishaw Vid, can you share insights on how to make professional looking cases beyond 3D printing for your electronic boards? Yeah, that's actually quite a big and interesting topic, and I'm going to, there's a video that I'm working on at the moment which touches on that, and there are a few different approaches to it. One approach that I like I'm just trying to think about how to answer this in a concise way, because I could go on about this for quite a long time. As a general principle, what I like to do is design projects around off-the-shelf cases, unless it's going to be done in volume. And the reason for that is that you can take a cheap off-the-shelf case design and then make your board fit into it and end up with a very professional looking product with minimal effort. And for a lot of these cases, they are produced in quite large volumes. If you are designing your own case, then you've got to amortize the tooling costs and everything else across however many you're going to make. But there are suppliers, like specialist case suppliers on AliExpress, like there's one called SZOMK, which is, SZ is obviously Shenzhen. I don't know what OMK stands for, but it's a Chinese company that manufactures plastic cases in all sorts of different types. Like they've got literally thousands of case designs, and they range from cases for handheld devices to, desk equipment and industrial enclosures and all sorts of different things. And they can be customized as well. So what you can do is look through their catalog, find a case that approximately suits what you want, and then either just buy a couple of them and modify them yourself by drilling holes for connectors or whatever. Or you can say to them, I'd like 100 of those cases, but I need holes pre-drilled in them and slots and whatever, and these are the dimensions, and they'll take care of it for you. And because they are producing those cases in very large volumes, it means that you might only pay 50 cents or 70 cents for a case that is essentially like professional quality. And then by designing your circuit board around that case to suit the mounting lugs and the internal dimensions of the case, you can end up with a product that looks quite professional, but hasn't cost you in terms of doing custom case design. So I'm going to talk about that in a bit more detail in another video that's coming up. Just wondering if I've got an example. No, I could pull it out, but that would be preempting the next video. So I've got a board design which is a really bizarre shape, and it's not a rectangle, it goes in all sorts of weird shapes, and that is specifically to fit inside a cheap case so that it mounts onto all the correct mounting lugs and everything fits nicely. So I just find that making my PCB suit a case is often easier than making a case suit a PCB. And of course there is 3D printing, there's laser cutting there, and you can do vacuum molding and injection molding, and I'm probably going to go into a whole lot more detail about that sort of stuff in the future. One of the projects that my friend Andy Jalmy and I have been talking about is doing a custom case at a factory in China, and as we go through that process, I think we're going to end up documenting it and trying to share as much of that process as possible. So we'll get back to that. That's a big topic, but thanks for the question. So let's see. Questions. How do you track what parts you have in your own supplies? Bin labels, software. Oh, that's a big question. I have a project underway right now for a thing that just lets me locate the plastic containers. I'm not going to get into that because it's a huge one. I'm scrolling back in questions. Do you have experience in home energy monitoring, home energy consumption monitoring with Arduino? Question from CPY Andy. Short answer is yes. I actually have a lot of experience with that. I've done both commercial and my own personal projects in the past. I had a really interesting project a few years ago. Just wondering if I'll get into that story. No, I really need to get to the end of these questions so that I can finish. Energy consumption, yes, I actually have 2 videos partly filmed on that subject. I've done things with current clamps and like the little CTs, the current transformers, and I've also done it using pulse counting off the smart energy meter, and also using Sonoffs, which have Sonoff Power has built-in power monitoring. I've also done work with modifying commercial energy monitoring equipment and taking data out of that. I did a project quite a few years ago in the context of IVT, which is my software company that doesn't exist anymore, where we were taking energy data from sensors that were located all over at a school campus, and we were using Siemens energy monitoring data acquisition stuff for that. And then we did an interface which was a map of the school and overlaid a heat map onto it. So you could look at the overall picture of the school, and then buildings that were using a lot of power would be glowing bright red, and you could see where all of the power is going. Yeah, and I did a job for a shopping centre up in Sydney, which had some interesting consequences. I might talk about that some other time. Once again, I could go on about that stuff for hours. There's a comment here from You Can Dance. He did really just say, what? No, I did not just say that. I don't know who said that. I'm not even going to get into it. Don't feed the troll. Correct. Clayton says, hello from Trinidad in the Caribbean. Hello to Trinidad from Melbourne in the Australia. So every day do you have, Neil said, this is in relation to the robot lawnmower. Every day do you have Arduino powered grass? Yes, the lawnmower runs every day, and that is because it works on the principle that it's automatic, so I don't need to do anything, and it only trims a couple of millimeters off the grass each time. I've done many videos about the robot lawnmower and the process that it uses, so I won't get into that now. But if you look back on the episode list, you'll find plenty of information about that. Ooh, Dodgy Brother says, keen to see mower mods, working on a remote 48-inch cut mower myself. That sounds freaky. I would love to see that. A 48-inch mower, that's a really serious mower. And if you're doing that remote control, that could be interesting from an OH&S point of view. Peter Lawler just said very generously, hey John, don't necessarily want to contract you right now, but can I donate cash to help support your work and help of us, PayPal or Patreon? Well, that would be really appreciated. Thank you very much. And so I do have a Patreon account, and so I have a feeling that Peter might already be a Patreon supporter, and he's just saying this to prompt other people to support it. Thanks, Peter. So there is a Patreon account, and if you go to SuperHouse.tv, there is a link to it from there, and I really do appreciate it. And a comment from Rowie Benamots. Thank you for watching. I appreciate that too. And what else? If you're using OBS to stream, oh, okay. Neil just gave me some information about the streaming from the webcam. I'll remember that. I need to get on top of my streaming process. So, Rowan said, Big Clive uses an iron upside down in a vise, I think, to preheat boards. Interesting. I'll check that out. I assume that Big Clive will have that on his YouTube channel somewhere. Pyrotechnics, a slightly different effect. Okay. Dragon Monkey asked about the frequency of the RFID implant. He says 125 kilohertz or 13.56, which would be megahertz. Those are the two common frequency bands that you see for implanted tags. The answer is neither. It's actually 134.2 kilohertz, which is the ISO mandated standard for implantable RFID. Now, in America, it is really it's really common to see 125 kilohertz implanted RFID, and that is because the ISO standard was ratified after PET implantation became common in the US, and by that point, most companies were using 125 kilohertz, and so in America there is a bit of a mishmash of technologies. And it's kind of annoying from a vet's point of view, because if they find a stray animal, they need to scan for multiple types of tags. Everywhere else in the world, if a tag is implanted, it'll be it's to the ISO standard. It'll be 134.2 kilohertz with certain encoding schemes and things. So it's much more reliable. But if you're in the US and you're a vet trying to find the owner of an animal, you have to scan it with different different technologies, because it could be any one of a number of things. So, Jason asked, don't need to cover this on the live stream. Well, I'm doing it anyway, but have you thought of selling t-shirts? I've thought of making some for myself. Maybe. Spider Eye said, where I used to work, someone had an RFID in one hand and another type of chip in the other, then a small magnet in one of her fingers. Not my cup of tea, I'll stick with keys. Fair enough. Yeah, the magnet implants are interesting. That's, once again, I can get into that in detail as well. I know a few people with magnet implants, and they do allow some interesting tricks that you wouldn't have thought of. Body modification place, questions. 503 Ali says, I have two implants, one 125 kilohertz RFID and 13.5 megahertz NFC. Yep, cool. I think that's fairly, those are the two common technologies. So if I was getting another implant now, I think I would get the NFC type. There is some cool development work being done over at Dangerous Prototypes. Amal Grufstra has been working on a little tag called the Flex NT, and when he was in Australia a little while ago, I met up with him in Sydney, and he showed me prototypes of the Flex NT at the time. And since then, I think he's been doing a whole lot more work with tags that have other features, so they can pretend to be different types of cards. So another big topic. Okay. Peter says, oh yeah, I'd go for a SuperHouse t-shirt or two for when I'm crawling around under my house. Yep. That's when you wear the old t-shirts that you don't care about anymore. So I've just about caught up, and I'm now 2.5 hours into a 1 hour live stream, and I think I need to get better at controlling my own time and stopping when I was intending to stop. But I'd just like to say a huge thank you to everybody for coming along to this. It's actually really fun doing this sort of thing, and I like I like getting the feedback and the live comments. And when I do regular videos, I record them and edit them and then upload them, and I kind of get down about a lot of the comments, so a lot of the time I don't go back. Like, I'll go back sometimes and look at comments and answer some, but there's not really that level of interaction. And I really like the two-way process of doing this as a live stream and having these questions. So, oh yeah, Gary S. said, in one of your videos you mentioned you were going to get your mower to tunnel under the house to do the front lawn. Might have missed a follow-up video. Did you ever do that? Not yet, but I've got some of the stuff that I need. A fair bit of this project is mechanical. It's just making the door under the house and putting through... now, under my house is not... At the moment it's not clear, so there's no physical way that the mower can get through. So what I need to do is make a little ramp that goes through. I've got material for that, and I've also recently got hold of a couple of motors with some gearing and things that I can use for opening and closing the door to let the mower through. So I'm intending to follow up on that project, and that should be interesting. Not just electronics, but actual getting out and physical fabrication of things as well. So, Seabreeze Coffee Roaster says, thanks for the ramble. Yes, it feels like I've been rambling. And yeah, thanks to everybody for coming along. This will be up on YouTube. I assume that it gets archived and uploaded or whatever as part of this whole live stream process. So I'm going to end the live stream now and go and get something to eat, and maybe get on with doing some recording of some other videos. I've got, a couple of days ago, I started recording a video about showing how to reflash every Sonoff model that I have. So maybe I will get back onto that one. So thank you very much, everybody. On Robert Poynton said, never get down, mate. The negative people are louder than the positive people, but we are here. Yeah, thanks. I really appreciate that. All right. Have a great Sunday morning, if that's what it is for you, or Saturday night, or whatever the time is. And I will see you soon. Bye.